Dear all, good day. Today is my 53rd lecture, and the subject matter on this lecture is, as you can see on top on the menu part, it's regarding the passage planning. Now, when I talk about the passage planning, I'm going to basically now broadcast the series of passage planning, taking into consideration all the aspects wide sire 2 decimal 0. Prior to that, on the preamble, we'll talk about few things, and then as we go down the rung, we will see the parts what I have basically divided in order to explain at length to all my mariners, my colleagues, so that no scope of doubt is left. I hope I will try to persevere as far as this subject matter of comprehensive passage planning is concerned, in a very narrative manner, to make my colleagues, my comrades, my fellow mariners understand this, and to make you perceive the subject matter in a very narrative manner and in a very explanatory way, the way I have made the slides. So we begin under my banner of Marine Quest Solutions, the lecture number 53. Of course, it is Comprehensive Passage Planning Series Part 1. Now, when we talk about the passage planning, it has to be first berth to berth. In other words, like for example, if a vessel is departing a port from the berth, so the legs involved would be from the berth where the pilot embarks when the vessel is casting off till the pilot drop off. Then from pilot drop off to the coastal passage. Once the coastal passage is over, that is the second leg, the coastal passage. Third leg would be the open sea or ocean passage, subject to where the vessel is heading for. And the fourth passage would be again a coastal passage or critical passage. And the fifth and last would be up to pilot station, and or in case vessel doesn't have a berth there, then it would be from the coastal passage or critical passage up to the anchorage. That is the next leg. And in case the pilot doesn't come on at the anchorage, then from anchorage to berth will be the next leg. So this is how the passage plan should be made comprehensively, taking all the parameters into account, be it the squat, UKC calculation, each and everything, your waypoints, your weather warnings, your Navtex warning, taking everything into consideration for each and every leg. So the passage planning should be from berth to berth up to the specified point as per the vessel's voyage orders, involves whatever the voyage order says. The four major stages in chronological order, which I have stated down, namely, which of course most of us are aware of it, are appraisal, planning, execution, and monitoring. Now, by and large, what I've come across after after being a sailing master for almost 23 odd years and serving sea for more than 4 decades, that somewhere down the line, when we talk about the passage planning or lots of other navigational aspects or even the cargo aspects, the practical knowledge of the seamanship is completely, for some reason or the other, without prejudice, I'm making this statement, is becoming null and void or getting devoid as far as our mariners are concerned, maybe because of over-reliance on a lot of other aspects, which we'll see as we go down the round. So that is the reason I've stated that each stage in the passage planning has its own significance, and it is imperative to exercise due diligence, keeping the objective of the safety of navigation as paramount, in cognizance with the practical knowledge of the seamanship. Now, the four parameters what I written down here, that is number 1, 2, 3, 4 respectively, that is appraisal, planning, execution and monitoring. What do that mean? I'll explain to you in a nutshell. That is, appraisal is a collecting and assessing at relevant information required for the intended passage. That you collect all the data. If you get to know, as per the voyage orders, that you're going from point A to point B, and during your route, what all publication charts, the navigational publication charts, or anything and everything required for your navigational aspect do you have? You have to assimilate the data and collect it, and start working on it. That is your initial appraisal. Planning. Once you have all the charts, publication and all the things what you require, thereafter you start developing and approving a passage plan based on the outcome of the appraisal of all the relevant information. So first stage is you get all the relevant information either from the sailing directions, that is your electronic sailing directions, your charts, your publications, whatever the data you can assimilate, be it a coastal passage or a ocean passage, be it from your NP 100 or from your ship routing guide, whatever is relevant, you need to collect all the data and assimilate it once you have procured them. Execution. The briefing the bridge and the engine team on the passage plan, navigating the ship in accordance with the passage plan. So execution is the third stage, where you basically brief the bridge and the engine room team that once a passage plan is prepared, that what all are the critical aspects of the passage plan, be it your UKC, your depth, draft constraints, or anything which is hampering your safety of navigation. All those things come into the third stage, that you have already taken the assessment of all the aspects of your comprehensive passage planning, and now you're aware of it. You're also briefing. This is from the master and the navigating officer's perspective, because initial briefing is between master and the second mate. Once the second mate collects under the master's authorization all the data whatever is required, be it chart, publication, as I said earlier, and then second mate draws the courses and prepares a passage plan, shows it to the master. Once the master approves, thereafter comes the execution state, that okay, master has approved the passage plan. Thereafter, all the navigating officers, the engineer officers are to be briefed that this is the passage what it is going to be, and what all are the critical aspects, be it from your critical passage, depth, draft, or anything and everything, and what all are the hazards as far as the navigation is concerned, shall be briefed to all the personnel, because in end of the day, it's a bridge and engine room team which work together cohesively. The fourth and the last stage is monitoring, that is checking the ship's progress against the passage plan. So stage number 1, you've collected all the data what you require for the present or current passage as per voyage order. Number 2, that you have developed the passage plan in concurrence with the master, and the courses, everything has been laid down in a very elaborative manner, in a very comprehensive manner. Once all that is done, it has been concurred between the navigating officer and the master that yes, if there's something else to be done, if not, then it is like kind of a partial approval, because the third stage prior to the execution, all the members are brought together and the whole passage is discussed, and the feedback is taken in case some nitty-gritties are involved or fine-tuning is involved. And last but not the least, the final stage is monitoring, that is checking the execution of the passage when you are checking the ship's progress against the intended passage plan. So these are the 4 stages, which is, of course, we are well aware of it: appraisal, planning, execution and monitoring. Now we go to the next slide. The format of the passage plan and the minimum information that must be included, which should include but not limited to. What are those? Now that's where I have delineated the whole comprehensive passage planning in 6 parts. The reason being is not to overload you guys, so I will be today narrating or describing in detail regarding part 1. Thereafter, subsequently, part 2, part 3, part 4, part 5, and part 6 accordingly with respect to my lecture. Like this one is 53, which is part 1, 54 will be part 2, 55 will be part 3, and so on. So, today what we are going to talk about, the part 1, which is parallel indexing, not from the floating objects unless they have been checked for position. The details will go about it when I come to part 1, detailed narration. Point number 2 in part 1 is chart changes. Point number 3, method and frequency of position fixing and or position verification. This is a very important aspect which I have detailed in a very, narrative or comprehensive manner for the people to understand this. And last but not the least, under part 1 is prominent navigation and radar marks. We'll talk about as we go about it. Right now, this is a preamble. Part 2, I'll be broadcasting under lecture number 54 will be no-go areas, landfall targets and lights, clearing lines and the bearings, transit heading marks and the leading lines, and significant tides or the currents. This will be part lecture number 54, which I'll be broadcasting in next few days after this lecture. The next lecture, the next part, that is lecture number 55, will be part 3. That will be safe speed and necessary speed alterations, change in machinery status, that is the manned and unmanned engine room respectively, changes in machinery status, that is the standby for maneuvering, changes in bridge watch composition. All these parameters I've taken from SIRE 2.0 to explain all the mariners in a very detailed manner. So we go to the next slide. So part 3 will be 55, lecture number 55, which will be broadcast in due course. This one, the existing lectures 53, 54 and 55. The next point we go to, that will be part 4, will be 56. That is changes to fuel and or scrubber use. As we know that lots of ships are changing over to LNG and a lot of other fuels. We'll talk about at detail at length on that. Changes in security level, minimum UKC under keel clearance, for which I have already broadcast my last lecture 52, which I will be again reposting on this platform in part number 4. And positions where the echo sounders should be activated, crossing and high traffic density area, all this will be part and parcel of part 4. Part 5 will be safe distance off, navigating hazards or marks, anchor clearance, contingency plans, abort positions. Anchor clearance and all these things I've described at length in my anchorage series or safe anchoring procedure series. You can watch it, but I will again be coming up with more nitty-gritties as per your feedback. What else you want to know besides those 3 lectures I have broadcast on anchoring series. So this is part 5. And of course contingency plan and abort position part 5, which it concludes the part 5 as per what I have drawn here. Part 6, the final will be regarding VTS and reporting points, etc. Air drafts when passing under the bridges, power cables, cable cars, etc. Alternative to the contingency routing that may be required at short notice. That is in case you have any deviation or for some reason the vessel has to deviate from our original track, what all things to be done, we'll talk about in part 6. Specific guidelines provided by the local routing publications where applicable to the vessel and its route. So part 6 will be all about that, and we'll talk about, just to do the justice with each and every part. That is the reason I divided. Number 1 is not to overload you. Number 2, to explain at length in a very narrative manner and do the justice with the subject matter from my side. The process to verify that all the navigational and environmental considerations have been included in the final passage planning. That is, this process is there to verify that all the navigational and environmental considerations have been included in the final passage planning. Now, this is all from the SIRE 2.0. The review and the approval process of for the passage plan, including utilizing the ECDIS route checking function, the record keeping requirement as they relate to the progress of the passage plan and navigational events. The actions to take to update passage plan when circumstances change, requiring the vessel to deviate from originally agreed passage plan. This is what I said few minutes earlier. The requirement for preparing passage planning on both paper charts and ECDIS, where the vessel has a single ECDIS unit or has a nominated paper charts as a primary means of navigation as per your SEQ. If some of the ships still probably must be sailing with single ECDIS, and subsequently they have to maintain the chart folio, and the whole passage plan what is drawn on the chart has to be replicated on the ECDIS or vice versa. The requirement for a passage plan briefing, including the master, all the navigating officers, and a representative from the engineering department. That means when we are doing the passage plan meeting, that is pre-arrival or pre-departure, the master and all the navigating officers are mustered there on the bridge, along with, I would say, what I had been doing, chief engineer and second engineer, because one of us there for the maneuvering, keeping their, work and rest hour timing. So these two key personnel from the engine room shall also be present when master is, detailing the passage plan in, along with the navigating officer. So each and every person or part of the team is on the same page and in concurrence with the existing passage plan. So this part is very important. That is the reason I've underscored this with red line. A vessel should be expected to deviate from planned passage to the extent necessary to safely comply with the collision regulations. Due consideration should be given to such when apprising the passage and developing the plan to ensure that there is an adequate sea room and the watch conditions are appropriate. So this is again an important point, that due consideration should be given to such cases when apprising the passage and developing a plan to ensure that there is an adequate sea room at each and every leg, at each and every between each and every waypoint as well, respectively. That is, in case the vessel has to deviate, or if there are any changes of orders, voyage orders, or if the vessel has to go immediately for some rescue, in case the vessel is nominated for that. Now, part 1, we come to this part 1, what I had chalked down here. Part 1, first is parallel indexing, second is chart changes, third is methods and frequency of position fixing and or position verification, and prominent navigation and radar marks. So this is what we are going to cover up today in under the lecture number 53, part 1. However, the whole curriculum, what I'm going to do, I have already described to all my fellow mariners and my followers world over, because this particular lecture I was thinking to broadcast after I got so many queries, not only from the navigating officers but also from few of my comrades, my masters, my colleagues, etc. So part 1, the parallel indexing, not from floating object unless they have first been checked for position. Now let's say logical conclusion. Why don't we do the parallel indexing with the buoys? Because buoys are kind of are floating objects, and they are kept in a position with the chain, like something similar to anchor chain what we have, and few anchors, because the anchor chains with which they fix the buoys, they also have a catenary. So at any point in time, the geographical position of the buoys or floating objects will vary. That is the reason it is imperative not to do the parallel indexing or cross index range, PI or CIR. I've written CIR also, that is cross index range, which is same as parallel indexing. So it shall never be done with floating objects like buoys. Yes, beacon, island, fixed objects, it can be done, but not from the floating objects. Now let's see this example what I've given, because during my sailing time and even my audits, inspections, I found many of the junior officers have not perceived, or they don't construe correctly as far as how and when and how to implement or how to do the PI. They may have a superficial knowledge, so this is for their benefit. In this case, I have drawn charted course 000 degrees, and there is a current effect which is pushing, that is on the starboard side of the vessel, is pushing the vessel, and she's making good a course of 350 degrees. The wind is also on the starboard side, which is further pushing the vessel as per the windage area. That's the example I've taken, and final course made good is 346. So in this case, the PI which you are going to do will be always on a 000 course, not on 350 and not on 346. I know it's a very basic thing, but when I had interviewed, even today also, I do a lot of work, I'm on a lot of companies, navigation and mentoring, as far as that is concerned, on their panel. When I ask these simple questions, it is not clearly understood. So come what may, doesn't matter what it happens, you have to make good, in this particular example, a course of 000, because with the effect of current and wind, you're making good a course of 350, and final course what you're making good is 346, but you have to make good the course of 000. So you have to give a starboard set, maybe 005 or 006, to make sure that your island, which is this one, maintains this this line. If the island is on this line, which is maybe two nautical miles away, and you are doing the PI or the parallel indexing, and you keep the island on this line, means you are on track. So make sure that this mistake, which is very common, at least amongst the junior officers who do not understand how to use this tool of PI. Many a times I've asked them, okay, in this case, if your charted course is 000, and with the effect of current, a strong current, it's pushing you on the port side, you're making good a course of 350, and with the effect of wind, final course what you're making good is 346. So what will be the course on which you will put the PI? You'll be surprised. Many of them, they said 346, some of them they said 350, forgetting the basics that no, you have to make good a course of 000, because 350 or 346 is the course made good, and you have to make good a course of 000 because that's your charted track. So this point has to be clearly understood. So PI or CIR, PI parallel indexing, CIR is cross index ranges, should always be on the charted course. That's what I said earlier. PI or CIR is also the tool to be used to demonstrate continuous monitoring of the vessel's position, especially when the PFI frequency becomes less than 10 minutes. PFI stands for, in this case, position fixing interval. In case you have a position fixing interval, which I've calculated, and I'll show it to you in next slide. In case your position fixing interval comes to less than 10 minutes and you are in a coastal passage, let's say you are in a coastal passage, it becomes difficult for you to plot the position when the PFI is less than 10 minutes every 5 or 6 or 7 minutes, because if you're doing it, because even if you plot the LOP, it will take you approximately 3 to 4 minutes. By such time you take a radar range bearing and then come to the egg disc and feed it. Even on the radar overlay, which is not acceptable, you must take a radar picture. You take the range and bearing from radar and then come and feed it onto the egg disc. It will take you approximately minimum 3 to 4 minutes. And if you're doing it, and if your PFI is 6 or 7 minutes, means you are basically becoming a position plotter. You're not paying attention to what is happening around you. As far as the traffic is concerned and the vessel movement is concerned. So, PI, parallel indexing or CIR is a tool to demonstrate in case your PFI, position fixing interval, comes to 5 or 6 minutes, you can plot every 12 or 13 or 15 minutes, as long as you can demonstrate that you're doing you're carrying out the continuous monitoring of the vessel's position by parallel indexing. So make no mistake on this aspect. So PI or CIR, that is the cross index ranges, is a tool to demonstrate or to suffice or to complement the position fixing interval in case the position fixing interval comes very small. We will see in the next slide. I've explained this at length. We go to the next slide now, that is chart changes and the points to ponder. This is I've taken from one of the checklists. And what all things to be taken, because chart changes, one may think like how we used to have paper charts, we used to put on paper chart, next chart, so and so. But besides that, there are a lot of other aspects which are to be taken into account. Number one, adequacy and reliability of the aids to navigation. Number two, adequacy and reliability of the charts and the hydrographic data. Number three, ENC charts with permits for the entire voyage available in the IGDIS catalog. All these diligence shall be carried out by the master and the navigating officers. ENC charts updated with the latest base and update CDs. In case of the use of RCDS mode operation in specific areas, are there sufficient and updated paper charts for backup use? So in case you have any dubious kind of situation like this, the vessel must also carry as a backup the paper charts. Confirm that WGS 84 has been selected on IGDIS, GPS and use charts. The following publications, that is electronic or paper, to be consulted and considered. That is large scale charts for coastal areas, coastal waters, small scale charts for ocean passages, larger scale charts for navigation, planning charts, routing chart, routing climate, pilot and the load line zone charts. Many a times this load line thing also happens, that when you're traversing from one zone, load line zone, to another, and in between you have a load line zone which is the minimum. Many a times a mariner makes this a big flout by not taking care of this as far as the load line rules are concerned. Load line rules shall also be strictly complied with. So in case you are traversing through this kind of passage where you've loaded the cargo as per your summer deadweight and you're coming to a winter zone, and then again your destination is in summer zone, so your restriction lies at the winter zone. You have to calculate that at the winter zone you're not breaching the winter load line at any cost, and that is the reason you have to take a complete appraisal of your load line zone charts as well. Then comes sailing directions and the pilot books. Of course, you have to take a cognizance with all these things, that in case any deviation, or if you're going into the ice area, whatever is the case applicable to you, all these things has to be taken into consideration when you're planning a passage. List of lights, list of radio signals, guide to port entry. Wherever you're going, you should have all these things. Tide tables and tidal streams, atlases. Like in English Channel, you have all the atlases, the tidal changes, and you have to carry that. And now you have electronic version also, but make sure you have all the data to basically simulate your position with respect to date, time. You get to know the latest tidal streams. Local area and warnings. Are there any local requirements of coastal states that may require carriage of additional publication or local charts consult your IHO website. That is the website address has been given. Like for instance, I remember when we are going to the Suez Canal. The Suez Canal authorities insist that you must have their local charts, even if you are fully ECDIS compliant as per your SEQ. Still, so as per the local regulations, and some places I've been there in Mexico where the ECDIS does not have a coverage. So make sure if you're going to those ports where the ECDIS coverage is not there as per the Her Majesty services, you must procure the local charts in advance prior to sailing towards your destination. So all these things are very important, and that is the reason I've included all these things into the chart changes. Nav area, navigational warnings, new charts and the licenses order as appropriate. So make sure that none of your licenses do expire. Of course, in case if it is expiring within another 15, 20, 30, 20 or 30 days and your voyage is for 35 days, yes, I understand you don't need to overlap this thing. You can order at least 2 or 3 days prior to its expiry. So, but make sure that due diligence is always, always exercised by master and the navigating officers. Please forgive me today. I've got a bit cold, so in case I hope my speech is loud and clear, but I have a little cold, but I'm trying to do the justice with the subject matter. Notices to mariners, which you get even on electronically also, but then make sure that all the charts are corrected, the ones which you are using, and due diligence shall be exercised even after you've got the information through the AIO. You must make sure, especially the second mate, with the physical documentary evidence of notices to mariners that all the charts are corrected up to date as per the latest notice to mariners, and physically check that no layer is missed out. Navigation chart and publications for landfall features. Navigation charts publications for ships, schemes, ships routing system, and vessel traffic services, VTS. Wherever it's applicable, the VTS areas should be marked conspicuously on each and every chart. Ship to shore master pilot exchange form prepared. That is, when you're coming to the pilotage water, master pilot exchange form shall be prepared in advance, and in case there are any more legal requirements as far as your chart publications are concerned, that should be strictly adhered to. Pilot cart is updated. Port guidelines, port guides studied for port information, including arrival, berth, and restrictions. That is, in case you have any draft restriction at berth, port, whatever it is, all that things have to be taken into consideration prior to committing to that passage. Voyage plan notes and the user's charts switch on to monitor mode. Voyage log, danger targets log, and the distance log should be reset. Voyage plan saved and loaded to secondary ECDIS. That is, once you prepare the whole passage plan, it has been concurred to that you have taken all the parameters into account, and thereafter you can replicate this or load the same thing into the slave master or slave ECDIS or to the secondary ECDIS. Now we come to the next point under part 1, that is method and frequency of position fixing and of position verification. Now, what all are the primary and secondary means of position fixing? Today, as I say, I think most of our mariners, what I've also come across my officers, they have very much over-reliance on the electronic aids to navigation. They forget about the basics. It's like back to basics. And that is where I'm insisting upon the practical knowledge of the seamanship. Like I've asked, I will probably broadcast another lecture that what would a duty officer do or a master do when you have, hypothetically, but when I put this question to many masters, I think 99.99% of the masters cannot answer. That is, suppose you are in the coastal passage. You are so far taking LOPs and all that. Maybe you have two gyros or one gyro. Hypothetically speaking, your gyro fails. The question I asked the mariners, how would you plot the position or how would you take the LOP on the egg disc? Not many guys can answer. Some guys do answer okay with the ranges. Then I put another lacuna. What if your VRM has got some error? I've explained this in short nutshell. You will get this thing message reading between the lines, but in case you have further doubt, I will explain. Like I have already broadcast a lecture in case the vessel is 24 nautical miles off the coast and you have an egg disc failure. You have a complete shutdown of the egg disc. You don't have paper chart. What action shall be taken by the master? Again, I would say 100% of the masters could not answer. And that is what I'm trying to say. The emergency contingency measures. And that comes nothing but with your practical knowledge of the seamanship. And that is what I harp upon, and I'm going to talk about it again and again because that is what is missing in our mariners. 4 odd decades ago when we joined sea, we did not have all this state-of-the-art equipment. It was all about our practical knowledge of our seamanship as well as having a complete appraisal of the electronic aids or electronic equipment what we had, because we used to read the manual, because all these electronic aids for navigation have limitations. This has also been mentioned in the coal rigs, that spurious information or the limitation of your aids for navigation shall also be taken into account. End of the day, you are the person. So basically, it's a man and machine interface. So during coastal passage, primary means of position fixing, that is visual bearings, cross bearings with a separation of approximate 60 degrees or more, because once you have more than 60 degrees bearing, you get a good cut, otherwise you may get a cocked hat. Along with the PI and cross index ranges for continuous monitoring of the vessel's position. So you can take 2 or 3 bearings, approximately 60 odd degrees, difference or separation between them, and at the same time you do the PI. So you have a kind of 100% redundancy as far as your position fixing is concerned. This is for the coastal passage. Point number 2, visual bearing and radar distance. So we have checked visual bearing, radar distance. Visual bearings, we have taken 3-4 bearings or 3 bearings. We have plotted. We are also trying to assess it once we have plotted that if your position shows online, is it matching with your CIR or PI or not? That is the first method. Second is visual bearing and radar distance. Third is radar bearing and distance. Ensure no error and gyro heading. No error on the radar and the gyro heading, because you have to make sure that even though when you're taking a radar fix, your gyro, whatever heading it is showing, your radar should also show exactly the same heading. Otherwise, you may have 1 or 2 degrees error in the bearing when you're plotting the position with EBL and the VRM. So, radar bearing and distance, ensure no error on radar and gyro headings. Verification of the VRM accuracy. This is the point I'm trying to tell you. Verification of the VRM accuracy with fixed range rings to obviate any radar range error. We have this basic function on radar, but not many mariners know what to do. And that's what I'm saying. When you have a gyro failure, you don't have a bearing. The answer comes to me that, okay, we can take from VRM. That too also after a lot of difficulty, not like it comes like this. But when I put a question, what if your VRM has got an error? No, not, I would say 100% of people could not answer. And the tool what you have here is fixed range rings. You need to overlap your VRM on the fixed range rings. You get the variance 0.2, 0.1, that same error at that range. You can apply it on the egg disc when you're putting the LOP. You can get the LOP. Not a rocket science. So, the secondary means radar fixes and DGPS or GPS fixes along with comparison. That is the secondary means of position fixing. You can use DGPS because during coastal passage DGPS is active, and GPS fixes along with comparison with as stated in the point number 1, 2, 3. So you should alternate, maybe If your PFI is coming 10 minutes, you must first plot, let's say the radar fixes or visual fixes. At the same time, compare the DGPS or GPS fixes along with radar or visual fixes to make sure that your GPS is showing no error. That is very important. Then comes affirmation of DGPS position with echo sounder depth and depth contours. This is normal, practical knowledge of seamanship. You can check it when you calculate that, your draft is this much and what is the charted datum showing. You can take the SCOT into account, then you know approximately, this is the UKC. So this gives you also an idea as far as your position fix, method of position fixing is concerned. Then comes open ocean passages. It is by GPS, DGPS as appropriate. If you get the beacon signal, the GPS will work, or DGPS will work as a DGPS. In case you don't have a beacon, which is electronically acquired in the DGPS, then your DGPS will be working on GPS mode, and of course site calculation. Because today, when I see during my sailing time also, if I ask my second mate, third mate, or mate to calculate long by cron or in meridian passage, latitude by meridian passage, very sorry to say, not even a single guy could calculate. Forget about that. Even the errors of sextant, the people were unaware of it. They only know index error, side error. What about if I ask some error of perpendicularity? Lots of other errors they don't know. And even index error, what it is, they don't know. They just know index error is 2 degrees off the arc or 3 degrees on the arc, etc., etc. And what is side error? How do you do that? They don't know it. So back to basics. This is what I would, try to promulgate in my mariners. Because in case you have failure of electronic aids to navigation, your practical knowledge of seamanship always prevails and saves you. Now we come to the PFI, position fixing interval as per the topography and the proximity of the navigational aspects. The principles of the PFI. What is the principle of position fixing interval? That between any two given positions, the vessel shall not be into any danger. That is, between any two consecutive position fixings, the vessel shall not be running into any danger. So the example I've chalked out here is between point A and B. Let's say prior to point A, you are in open sea. Let me mark it here for everyone's benefit, that you are in open sea over here. And again, when you exit this passage, you are again going to open sea. Now the point to ponder, or the question what I intend to ask you, is that what will be the PFI between point A and point B? Between point A and point B. When you are going on a course of 045, 12 knots, here you are coming up from open sea, and again after this point, maybe let's say this is 6 to 8 miles of distance between point A and B, and you are going back to the open sea. You can come to your 30 minutes interval as per company specified instructions. But what would be the PFI between A and B? That's my question. Taking into consideration that between any two consecutive positions, the vessel shall not be running into danger. That's what I described earlier, that between any two given positions, the vessel shall not be running into danger. That is the principles of PFI. And also marking cross-track errors as a margin of safety. We know we have a cross-track error. We can always mark on ECDISC and feed it on ECDISC or GPS. That will give you margins of safety. That should also not be undermined. Now let's talk about how to go about PFI in this case when you're going on a course of 045, 12 knots, and there's an island here which is 2 nautical miles off you. So how do we calculate this? To delineate PFI between point A and B when the vessel has an island 2.0 miles nautical miles off the course, vessel on a course of 045, 12 knots. So the calculation goes, the distance of the nearest danger, that is 2 miles, divided by the speed of the vessel, which is 12 knots, multiplied by 60, and the whole thing is divided by 2. And that's where the principle of PFI it is. Why it is divided by 2, that is between any two given positions, the vessel shall not be running into any danger. So we divide this by 2 and your PFI comes as 5 minutes. Now the next question to ask that if the PFI is 5 minutes, it's not humanly possible, especially if you have traffic, fishing traffic or some other constraints, then it shall be demonstrated by the continuous monitoring of the vessel's position by PI or CIR. So these are the tools what we can use it in our favor. I hope regarding the PFI I have been able to explain it in a very comprehensive manner. I hope I have been able to narrate that clearly. But again, for the benefit of all the mariners, that I need to know what should be the PFI between point A and B, especially when the vessel is on a course of 045 12 knots, and there's a danger or an island which is 2 nautical miles here. Prior to that, vessel is coming from open sea, and after point B, she is again heading for open sea. So then there is no problem because there is no land, no object, nothing. So the distance of the nearest land, that is 2 nautical miles, divided by 12, which is the speed of the vessel, multiplied by 60, whole divided by 2, bases the principles of PFI. The whole thing calculation comes to 5 minutes. When it comes to 5 minutes, it's not sometimes possible to, put your PFI. That is the reason I chose this example. So you cannot, 5 minutes sometimes, because as I said, you may take 3, depends how fast or how well familiarized or accustomed you are there with the egg disk which you're working upon. Normally you take 3 minutes, maybe 4 minutes. So by such time you plot the first position, time to take second one, so that means you're not paying any attention to traffic or you're not complying with the navigation duties. In that case, the only thing what you can do is complementing the PFI with the PI, parallel indexing. And that is what it is, continuous monitoring of the vessel's position. Last topic for this part 1 is prominent navigation and radar marks. Assessment and marking of the visual as well as radar conspicuous navigational marks as per the topography. Now when the passage plan is made, the second mate and the master should pay attention, as per the topography of the area where you're traversing, especially during the coastal passage. You have a mountain, you have a cathedral, you have some other conspicuous target, you may have leading lights. So all those things shall be taken into account during the phases of passage plan and marked conspicuously that this point is a radar conspicuous, this point will be sighted visually with respect to your list of lights, and also having a detail from the pilots or the sailing directions respectively. So, prominent navigational and radar marks shall be conspicuous. The ones which could be conspicuous shall be positively marked on the chart and also specified in your passage planning accordingly. So just to narrate that visual bearings, where you can take a visual bearing, during in a good visibility, of course, and what is the luminosity of light at night. So all those calculations shall be done, shall be carried out by second mate. That how luminous would it be as per your height of eye, the luminosity and the nominal range, etc., etc. All those things shall be done. Radar range and the bearing using variable range mark (VRMs) and electronic bearing (EBL), of course. Radar conspicuous targets, objects. Transit bearing and clearing ranges. Transit bearing, that your leading lights, and the clearing ranges we'll talk about when we go subsequently, but all those things should be taken into account when you talk about prominent navigation and radar marks. Running fixes, where if you can take running fixes, which is on old method, it is not redundant, so do practice the running fixes method. Fixing by a line of sounding by contour, what I explained a few minutes earlier, shall also be exercised. So all these things shall be taken in cognizance by master and all the mariners. Horizontal sextant angle. I'm sure not many of the mariners today, and I'm saying without prejudice, would not be able to do it. We had done it. We had done it when we did not have the GPS era. When we were sailing around the arc or around the corner, we used to use the horizontal sextant angle and calculate everything. Or take a vertical sextant angle as per the trigonometry and calculate the distance off. We had done it. That is the reason all these things. So in case, especially second mates, and even master, if you have not taken side, I would say do get used to it. It is a requirement, but I would rather recommend for your own benefit. Rest, I will leave it to you. So horizontal sextant angles, positions by celestial means sextant, of course, either by long bicron in the morning or by latitude by meridian. Do practice it, because you have GPS when you're in open ocean, especially second mates, masters. Do practice it. It's actually a fun, like when you calculate. We used to calculate the sites, that there used to be competition. Those days we used to have two sextants, so who would calculate it faster? And those days we did not have even the scientific calculators. We used to calculate through Norries or Burton tables. Position by celestial sextant I've already talked about. And if ARPA overlay is used, targets not acquired by ARPA will not appear on the egg disk. Similarly, targets not fitted with AIS will not appear on egg disk. I hope you guys know that. Therefore, egg disk should not be used as primary means of CAS. I asked one question to most of the mariners when I interview them. Why do we use log speed, where the GPS speed or the speed over ground is more accurate? Why do we use the log speed on ARPA? It is always mentioned on the ARPA. Think about it. If you don't get the answer, I certainly will answer this question, but this is the part of the homework. So as far as part 1 is concerned, we have concluded the whole lecture. Just to sum up, first part was parallel indexing or CIR, which is not to be taken from the floating objects, chart changes, methods and frequency of position fixing and of position verifications, and prominent navigation and radar marks. This was lecture number 53, part 1. 54, I'll be going down the rung this way: no-go areas, landfall and lights, flaring lights and lines and bearings, transit heading marks and leading lines, and significant tides or currents. So I will be coming back to you, or I'll upload the next lecture, part 2, under lecture number 54. I hope this session would have been of some help to all my mariners. Do let me know how did you find it. And I wish you all the best. Stay safe. Have safe sailing. And good day. Thank you. I sign off.